Hello everyone, I am Suputra Panchal, Assistant Professor, Department of Computer Science and Engineering, BADS VP Dr. PG Halkatti College of Engineering and Technology, Vijaypur. In the last class, we have discussed about codebook cipher, and along with that, in the last class, we have discussed the double transposition cipher, one-time pad. So along with that, some examples. Now in this class, we will be discussing some of the application of transposition cipher, that is double transposition cipher, along with that codebook cipher. So that is one best example in this is election of 1986. So now here still so we are discussing about that module level outcome. So we are in module 1.2, sorry, module outcome 1.2, that is study and analyze the traditional methods. Now we are in the applications of such methods. Now we will be shifting to the third module level outcome, that is analyze the simple cipher and substitution methods. So here this is one event happened. I think that is the election of 1876 between two different between in one country. So that is between Rutherford Hayes versus Swidling Tilden. So these two member has to stand for a particular election. So there is something else. Popular vote was virtual tie. So popular votes are going to be given for such members. What happened in this is electoral college delegations for four states. So there will be voting to be happened among four states, including, I think there is one country mentioned, including Florida in dispute. So what happens? Commission gave all states, that is electoral commission gave all four states to Hayes, voted on straight party lines. I mean, it simply means that Hayes is going to be win in this particular election of 1876. So what Tilden does is Tilden accused Hayes of bribery. I mean, there is something happened in this election. So we need to check, right? Was it true? So this is just an event. So for in such election also, some cryptographic concepts are used for voting purpose, for keeping the information secret. So in this, what happens? Encrypted messages by, there are some messages which are to be encrypted by Tilden supporters. So there are two members. One is Rutherford and another one is Tilden. Later emerged cipher. So what actually, how actually such messages are encrypted? So how they are going to get cipher text? Here, what they have used is they have used partial codebook. I think in the last class we have discussed how exactly that codebook cipher works. It's very simple. Uh, so for any particular message, for each word there is a particular code, and that code is to be placed in the codebook. And by referring that codebook, uh, a particular receiver, authorized receiver, can decrypt such codebook with particular order by adding some additive information that I have discussed in the last class. So, but here in this for encrypting messages in this particular election, so what they have used is two things. One is to get only the ciphertext. They have used a combination of cryptographic methods. One is partial codebook, along with that transposition. So how exactly they have used codebook substitution for important words. So here there is some example here. There is a ciphertext. Say for example, here we have Copenhagen. This is ciphertext. For the ciphertext, the respective plain text is greenback. So Hayes is to be encrypted as Greece. Oates is to be encrypted as Rochester, and Tilden is to be encrypted as Russia. I mean, whatever there are, there is something which are very important words. Only such words are to be encrypted in this election, in this particular election. And say for example, Telegram is to be encrypted as Warsaw. So, but how this can be done? How they have used partial codebook along with that transposition in that election of 1876. So here it's very simple. Apply codebook. Initially, in the first step, what we need to do is there is a plain text or the original message. For the original message, we need to apply codebook cipher to that, and so that we can get some of the codes in the codebook. And later onwards, what we need to do is we have to pad a message to multiple of 5 words. We'll be considering 5 words uh, as a sequence. For each 5 words, what we need to do is we have to apply a padding for that. So here it is in the form of total length. Here it's considered as maybe 5 words, then 10, 15, 20, 25 or 30. Like that, we need to pad a message for each length, whatever the length may be among these. For each length, a fixed permutation applied to resulting message. What resulting message will get it for that message? Fixed permutation. Permutation is already we have discussed about that transposition, the double transposition. What we have done before that, simple substitution cipher. That is nothing but a permutation here. I think we have discussed that row permutation, column permutation, all those. So next, what we need to do is permutations found by comparing several messages of same length. So here in this, actually every time same permutations will be applied. I mean same keys will be applied for after padding, after retrieving from codebook. So note that the same key is applied to all messages of a given length. It may be 10 words, it may be 15 words, whatever. But the same key is applied to all messages which are divided in that particular election. So this is what how exactly how exactly the messages are encrypted in the election of 1876. And there is the example is also given how exactly it is done. You can see here. So initially assume that the messages are encrypted using that using the combination of ciphertext techniques, that is partial codebook as well as transposition. And here we got a ciphertext. Ciphertext here is Warsaw. There is some confusion message here, right? Warsaw, they read all unchanged last or idiots can't situation. So here we got this particular as a ciphertext. But how exactly? Now what we need to do is we need to we try to decrypt this ciphertext. What actually the original message we get it, that we will check it. How actually it is applied. So initially codebook cipher is applied. Say for example codebook cipher in the sense in the previous you can see here in the previous slide, apply codebook to original message, whatever the original message is there for each words. So each word message is replaced with another codebook word, and we are also defined codebook is nothing but a unique numbers, but here codebook can also be considered as a messages or words. Here you can see that codebook in the codebook Vasha is replaced with telegram, that we have discussed in the previous slide. So for this, what we need to apply is codebook of course is only a single word here. So what we need to do is we need to replace this Warsaw with telegram. And after applying this codebook cipher, what we need to do is simple thing. We need to apply transposition with this particular sequence, that is a permutation here. Initially ninth location of the word is shifted to first location, third place. The word which is there in the third place is shifted to second. The word which is there in the sixth place from the skipper text is placed to third position. Like that, the word which is there in the first position, which is placed to fourth place in the process. Now, how exactly is? Now I'll tell you here. So here, very first step, Varsha is replaced by Telegram. Wherever you get Varsha in this Warsaw in this particular ciphertext, replace that with Telegram first. Now here there is only one word, that is Warsaw, that is replaced with what? Telegram. Now after replacing that Telegram, we need to count the number of words here. So here there are total, according to this permutation, totally there are 10 words. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now so where is the ninth word here in this is? Ninth word is can't. So that can't is placed first in the plain text. Then where is the third word in this is read. So that read is placed in the second position of the plain text. So now we got what? Can't read. Next, sixth word, last. Can't read last. Now we got in the plain text as can't read last. Now first one. Can't read. First one is Warsaw. Warsaw is nothing but telegram here. Can't read last telegram. So like that, we got it here. So next, tenth word. Tenth word is situation. Can't read last telegram situation. Now you can see here. Can't read last telegram. So situation. You can see that we can frame the sentence accordingly. Situation is what? Is at the fifth place. Then unchanged is at the, I mean, unchanged is at the fifth place. That is to be kept at sixth place in the plain text. Then second word is they. That is, that word is to be kept at, I mean, seventh place. Then what next is seventh word. That is seventh word. Here it is idiots. Idiots. Sorry. Wait. 1, 2, 3, 4, 5, 6, 7. Okay, seventh word. That is R is to be kept at. That is at the same position only. Seventh position. Then eighth position. Then fourth is there. That is all. 1, 2, 3, 4. That is to be kept at ninth position. Then word, which is eighth word, which is idiot. That is to be kept as last position in the plain text. So we got the plain text as can't read last telegram situation unchanged. They are all idiots. This is what the election of 1860. This is what that Tilden supporters did was they have kept some important information secret by performing the cryptographic by applying a cryptographic methods to that, that is partial codebook cipher, along with that permutation or whatever, or else transformation technique. This is how from cipher text they have analyzed to get it to plain text. So what we can say for this is a weak cipher made worse by reuse of key. Now here what happens, here we have applied this transformation for all important words for any type of code book. Wherever you want to decrypt the plain text, the same key was used. That is the reuse of key. Key was not changed every time. So for that, we can say this as a weak cipher made worse by reuse of key. So if the same key is used again and again, what hacker or what crypt analyzer does is that they tries to get the information that with the trial and error method by using the particular keys by viewing the cryptographic or else ciphertext information. Lesson: don't. So from this, what we can learn is don't overuse keys. That keys is to be used only once or twice, but it cannot be used multiple times again and again. So here, that's what in the early 20th century. So that is what you can call the WWI. These are all some of the uh, techniques happened for that election. I mean, happened for that cryptographic techniques. One is Zimmerman telegram. Gentlemen do not read each other's mail. That is what Henry L. Simpson, Secretary of State, 1929. Then one more event was WWII, Golden Age of Cryptanalysis. You know already what is cryptanalysis. Cryptanalysis is breaking the secret codes. So Medway or Coral Sea, Japanese purple, and they have used some code names like Magic or Ultra. So in the next class, I'll be discussing about some of the history of this. Cryptanalysis and all. So this is what how exactly that election of 1876 was conducted. Thank you.